Cuckoo hashing. Recently, we've talked about hash tables. That's a simple data structure where you use the hashed value of a key as the index location in an array, and Bloom filters, where you use multiple hash functions to reduce collisions in a bit array. Now let's combine those techniques in a data structure called the Cuckoo Hash. You stole my wife, and now you've got to pay. No, that's a cuckold hash. If you're not familiar with the basics of hash functions or hash tables, you might want to watch my videos on those two topics, or learn those some other way. It's up to you. One of the things left undefined in a hash table is what do you do when there's a collision? Different hash table implementations have different solutions to this problem. Some hash tables route a linked list at every node, or try. If you're building a cache, you can even just throw out any key that you run into. When inserting a value using cuckoo hashing, we hash the initial value twice, with two different hash functions, giving us two different locations in the table. If the first location is empty, we place the value there. If the first location is full, but the second location is empty, we place the value in the second location. If both locations are full, we place our value in the first location, bumping the existing item out of the way. But now we have a key value pair, key x1 to x1, that needs a home in this table. So we rehash key x1, giving us two hash locations, and we put x1 in its second location this time. If x1's second location is full, we bump whatever object is in that second location and put it in its own second hash location. We can keep on doing this until everything in the table has a place. Those of you in the audience paying close attention might notice that it's possible, if you're not careful, to encounter an infinite loop in the insert process. You have to keep track of locations you're inserting to, and if you encounter the same location twice, your only option is to rebuild the hash table.
Boop, 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 boop.
With hand-wavy math, it's possible to show that you're not likely to have to rebuild your table until it's at least 50% full. If we use 3 hash functions instead of just 2, that 50% jumps to 91%. So now our inserts can be a little sluggish, but all of our lookups are guaranteed to occur in constant time. Our item will always be in one of the hash locations we say it will be in, and with 3 hash functions we can still use 90% of the table. On top of that, and this is an important consideration, cuckoo hashes are really easy to implement. That's Cuckoo Hashes. Remember to like and subscribe, and thanks for watching.